So force, maybe for some of you, these symbols are not so familiar. So this is the V here is called final velocity. So let's write it down. Final velocity. U is initial velocity. A is acceleration. And T is time. And S is what's known as displacement. So what is displacement? Displacement is the same as position. So for example, if an object goes up this way and then down, all right, so it goes up and then falls straight down. Goes up and straight down. Let's say this one reached 0, so starting from 0, it reached 10 meters, and then it came straight down. Then the total distance is 20 because it went up 10 and then down 10, but displacement would be 0 because position, when it goes up and then comes back down, it's equal to the position would be the same as 0. So that's what displacement is all about. So it's all about position, where the particle is. That's position. And again, so this is S, which is displacement or position. U is initial velocity. I'm just wondering if I can turn this thing off. It's keep saying someone joined and someone left. That's really annoying. Incoming new user interface. Maybe. I don't know. Okay. So U, that's initial velocity, V, final velocity divided by 2, and this is time, and yeah, all these are variables. I explained it to you. Now, I think these equations show up in the first question here, in one of the first physics questions. So where is it? Like it's in the green one. If we scroll down to, let me just have a look. So it's in the green one. Unit 11. So we just scroll down to Unit 11. Yeah, question 36. So you guys can see these equations, right?
Okay.
So these equations should, after today's lesson, should not just be merely just letters and alphabets and things like that, but you guys will be able to visualize them, okay? So I hope you do that now. So suppose an object was initially, so you guys all know what meters per second is, right? So meters per second means, so let's say 10 meters per second, that means every second you're moving at 10 meters. So in like 10 seconds, you'll be moving like 100 meters, you know? And if you have 10 meters per second squared, this is a velocity, but this is acceleration. So 10 meters per second is the same as 10 meters per second every second. So this means every second you are increasing your velocity by 10 meters per second. So suppose let's say Usain Bolt is moving at 10 meters per second initially. And for example, let's say he accelerated 1 meters per second every second. And let's suppose that he did that for 5 seconds. 5 seconds. what would be his new velocity? So he's going at 10 meters per second, but after 1 second, his velocity would be 11 meters per second. His velocity would be 12 meters per second 2 seconds later, and 13 and 14 and 15, right? So the final velocity is given as initial velocity plus acceleration times by time. So if you are not accelerating, then the final velocity is just the same as the initial velocity. But if you are accelerating, then whatever the final velocity is, that is the initial velocity plus the contribution. I think someone's making a lot of background noise. Would you be able to sort of minimize that? Yeah. If you like, I'm not sure who you are, but yeah, anyway. So, I hope that makes sense. So initial velocity is 10. And every second you are increasing your velocity at 1 meters per second every second. And you go for 5 seconds, then you would be increasing your velocity by 5 meters per second. So you add that contribution to your already existing velocity, then you get 15 meters per second. So that's what that equation is all about. Okay. So whenever you see this equation, this equation shows up quite often, I think, in GAMSAT. So this equation should now be something that that makes sense. Any question here so far? Anyone? Now I'm going to talk about this equation right here. So this one is not shown in this booklet, so it's not here. So let me try that here. So Usain Bolt was running at 10 meters per second, and after 5 seconds he's moving at 15 meters per second, right? So this happened. Acceleration is 1 meters per second squared, and time is 5 seconds. So we understand through this equation that the final velocity would be 15. But what would be the total distance traveled by Usain Bolt over this 5 seconds? So he was already moving at 10 meters per second. So let's suppose that he didn't accelerate. Let's suppose that this was 0. All right, let's suppose that he just went for 5 seconds. Then this would be 10. So if he wasn't accelerating, then he would just be constantly moving this way at 10 meters per second for 5 seconds, right? So in that case, he would be moving, he would be covering just maybe a little bit shorter than this one here. It will be covering 50 meters, right? So that's 10 meters per second times by 5. Does that make sense? So that's equal to 50 meters. But because he is getting faster and faster and faster, he will be covering this extra distance, so which we don't know yet. All right? So there is a way to solve this one. So you can see in this region, he didn't accelerate. So he's going at 10 meters per second for 5 seconds, so that's 50 meters. But here it's 10 meters per second here, but at the end of the journey, it's 15 meters per second. So you can think, on average, he was going, if you take the average of 10 and 15 and divide this by 2, then on average he was going at, this is a 25 divided by 2, so on average he was going at 12.5 meters per second. So you can imagine this guy was not traveling this entire region at 15 meters per second. He wasn't going at 10 meters per second, but he was actually going, you can imagine, as if he was traveling all this region in 12.5 meters per second. All right, and he did that for 5 seconds, right? So you can actually multiply 12.5 by 5, then you get the answer. So the total distance is, I'm going to use S for that. So S is equal to, now it's equal to the average velocity the average velocity, times by the time, 5. Okay, then this is equal to 25 over 2 times by 5, and you get 125 over 2. Okay, so that's equal to 62.5 meters. That will be the distance. Okay, so that would be the extra distance traveled by Usain Bolt because he was accelerating. So that's up to there is 50, but this distance is 62.5, and this here is 12.5 meters. Any question here so far? Anyone? Is that all good?
Yeah.
All right. Now, so how do we, so we can derive an equation from it. So S is equal to initial velocity and final velocity, right? And then divide by 2, so that's the average of the two velocities. And then times by time. So that's my, that's the derivation of this equation. All right, so what this equation means is the initial velocity, that's the average velocity times by time. Now I'm going to derive this one right here. S is equal to ut plus half at squared. So I'm going to start from here. So we now understand visually what this equation means. And we know that the final velocity is equal to u plus at, isn't it? That's the first equation. So this is the first equation. This is the third equation. So I'm going to do it. What I'm going to do is I'm going to plug the first equation into the second equation right here. So this is equal to u plus velocity, final velocity is equal to this one, which is equal to, so replace this with all of this. So that's another u plus at divided by 2 times by time. So this is equal to then 2u plus, this is u plus u, that's 2u, at divided by 2 times by time. So that's equal to, you can see that this 2 and 2 cancels out. So this divided by this is just u, and this divided this is equal to at over 2, and that's times by time. So that gives you ut plus half, and this is att, so that's at squared. So that's the derivation of the number 2. All right, so we can actually use this equation to figure out the total distance covered by Usain Bolt. So let's have a look. So Usain Bolt was going at 10 meters per second, and his acceleration was 1 meters per second every second, and his time is 5. He did that for 5 seconds. So how much distance does he cover? Let's suppose that we didn't figure out the final velocity, which was 15 meters per second. So if you know this one, you can use the equation number 3, which is this one here. So this is actually number 3, sorry. I think the red color might be giving people a bit of a headache, so I'm going to change it to black color. So the advantage of, so if you know the final velocity, then you can use this one. But if you don't know the final velocity, but you know what the acceleration is, then you can use this one. So initial velocity is 10, and he did that for 5 seconds. So the distance traveled by Usain Bolt from this term would be 50 meters, right? And this is half times by acceleration, which is 1, times by time, which is equal to 5 square. This is equal to 50 plus this is half times 1 is half, and 5 square is 25. So that's equal to 50 plus 12.5. So that's equal to 62.5 meters again. So what this equation is telling you is this. So let's suppose the acceleration, there was no acceleration. Okay, so then this term is 0. Is that right? Then this will be just very simple equation. The distance traveled is speed times by time, something like that. So if you were going at 10 meters per second and you go for 5 seconds, then the distance traveled is of course 50 meters. but you have this bit here, so that last term there is the contribution from the acceleration. That's the extra distance that you cover because there is acceleration. All right, I hope that makes sense to you now. Now, we're going to cover the last equation. Actually, so the reason why I'm showing you this is because without such explanations, these equations will just be simply equations, and you wouldn't be able to visualize it in your head. So when you see this equation, you should know, oh, the final velocity is whatever initial velocity was, plus the contribution that comes from the fact that there was acceleration. And when you see this equation, you must see, oh, I just have to find the average velocity times by time. And when you see this equation, it means, well, whatever the distance is or displacement is, that is the displacement or distance covered by the initial velocity plus the contribution that comes from the acceleration. The last one that I'm showing you here is, I would say number 4, is equal to v squared equals to u squared plus 2as. And I'm not going to go into much detail to explain this one. You just have to understand that this equation is useful. So it's not really possible to visualize this in your head like these ones here. So you can do that one. You can visualize this one, this one, this one, but not this one, because velocity squared is like, if you have meters per second, that's what velocity is, and if you square it, what you're going to get is meters per second, meters square and seconds square, and you know that doesn't make any sense to anyone. So that's not really any quantity that we can perceive. So this equation is just useful whenever time is unknown. So if you don't know time, then you can use this one. I'm going to illustrate with an example later. Like number 1, this one has got time in it. This one's got time there as well. This one's got time there as well. So time is everywhere except this last equation. So these 4 equations are used to describe motion. Okay, so I hope that makes sense to you now. Any question here? Anyone? Anyone like to, even if you think it's really dumb question, that's fine. All right. Anyone? You can type something up, or here, or you can. I really hope you guys can sort of ask questions and interact here, because otherwise it's going to be like one-way lecture, and that's not really the way I teach. All good?
Yeah, so far it's been quite clear.
So Kanchana asked me, are all the formulas provided? What do you mean by that? Are you asking if the GAMSAT exam provides these formulas? Is that what you're asking? Yeah, are you asking me if these formulas are provided by GAMSAT when you actually sit the test? Yeah, they do, yeah. So as you can see, in this this is a GAMSAT problem. This is by official Acer, I think. Yeah, it's by Acer, yeah. And you can see that in these, yeah, it was question 36 or something, yeah. Yeah, you can see that it's provided here, right? Like that. Except the one that I gave you here, because that's really useful. So they don't want you guys to like be able to use it. Let me just close this up, close that up as well. Yeah, so they don't actually provide this one. they provide this one. Okay, so this one is going to be very, very useful. So I want you to actually memorize it, because in this GAMSAT problem here, I was able to like get many questions right. I think some of the questions right using this equation rather than this equation. Okay. Yeah. Okay, we're gonna try some. Have a look at some examples now. All right. Suppose you like for on surface of the Earth, by the way, the acceleration is for GAMSAT it's 10 meters per second squared. But you always have to know that usually the downward direction you have to assign negative value, and upward direction you have to assign positive value. So acceleration. So there's something called gravitational acceleration. Gravitational acceleration. And the symbol for that, of course, that's acceleration, so it's A. But we usually use G for that. G for gravitational acceleration, little g. And that is, in fact, negative 9.8. But in GAMSAT, they simplify it down to negative 10. They just approximate it as negative 10 meters per second square because you know, it's very simple, and you guys are not allowed to use calculator, so this is a nice number, isn't it? So I'm going to ask you this question. So if I throw an object at 100 meters, I want to know how long it takes to reach the maximum height. All right. So in that case, we can use the first equation. The first equation is v is equal to u plus at. So we know that final velocity, initial velocity here is 100, and final velocity here is 0. So by plugging these into this equation, you get 0 equals to 100. That's initial velocity. Meters, that's meters per second. That's how fast this is going. But over here, when you reach the top, it's gonna stop first, and then it's gonna slow down, and then eventually stop here, and then it's gonna go faster and faster and faster again. So this one is minus, so this is plus, but acceleration is here negative 9.8, so this is actually plus, and then minus 10. We're gonna use 10 because that's what GAMSAT uses, times by time. So this in fact simplifies down to 100 minus 10 t. And you can just figure out time using time equals to 100 divided by. So you can move this negative 10t to the other side. Then you get 10t equals to 100. And t is equal to just 100 divided by 10, which is equal to 10 seconds. 10 seconds. So what it means is this. You can think of it this way. Initially, you have 100. So think about it this way. Let's say you have 100 oranges. But every day, you're going to eat 10 oranges. And how long does it take to finish off these 100 oranges? The answer is, of course, 10 days, right? So your initial velocity is 100. But every second, the gravitational acceleration is going to eat away your initial velocity at a rate of 10, this must be negative, at a rate of, it's going to take away 10 meters per second every second. So definitely it's going to take 10 seconds, right? So that's what this equation is for. Now, how long, what's the height that it reaches there? Okay, if there was no acceleration and it was just constantly going at 100 meters per second, and it did that for, let's say, 10 seconds here, then of course it's going to reach 100 meters per second, and it goes for 10 seconds. then it would reach 1,000 meters. Is that right? 1,000 meters. That's the displacement. But that's definitely not going to be the case, because it wasn't going at 100 meters per second all the way to the top. It eventually slowed down. See that? So you can actually use, so you cannot do this one. You either have to use equation 2 or equation 3. So I want you to maybe try now and figure out the answer to the maximum. So S is the displacement, and you can think of that as the height. You can think of height as displacement. And I want you to use either this equation or this equation to figure out the maximum height. I want you to figure out the answer and type your answer on the chat room here. Someone's asking a question. Tanvir, you asked me, what about the acceleration from when it was when it went from, is gravity the only acceleration? What about the deceleration of the ball? Okay, so this was Tanvir's. Can you guys all see Tanvir's writing, or is that all blocked out? You guys can see his, okay. Maybe if you open up the, maybe from my screen you won't be able to see his question, but if you open up, if you just click on the chat button, then you'll be able to see his question. So he's asking, is it he or she? I don't know. Maybe she. Excuse me for if I got it wrong. Not very good with names. So she's asking, as a he. Okay. So gravity. All right. So here's the thing. Wherever the ball is, it doesn't matter where the ball is, the gravitational acceleration would be -10 everywhere. All right. So whether it's going up, whether it's going down, the gravitational acceleration is going to be -10. So here's the thing. If you're actually going up, so let's say velocity is that way, but acceleration is that way, then this would be slowing down. True, because velocity is that way, but acceleration is the rate. Listen very carefully. Acceleration is the rate at which velocity increases or decreases. All right. So if the velocity is that way, if the velocity is that way, then the particle is actually moving currently upward. But if the acceleration is that way, then it will be slowing down, because that's counteracting that. For example, if this was like 100 and this is like 10 meters per second square, negative, of course, this is positive meters per second, then it's still going to move up, but it's going to become 90 meters per second, and then 80 meters per second, and 70 meters per second, etc., etc. And then eventually it'll reach zero velocity, 0 meters per second. But the gravitational acceleration is still downward of -10 meters per second. That's gonna make this one now accelerate that way. So there is no velocity anymore. Once you reach 0 and there's still acceleration like this, then it's gonna become -10 meters per second, and then it's gonna go down to and become like 20 meters per second fast, and then 3 seconds later it'll be moving it down at 30 meters per second. Okay, because it's actually wrong to say this as gravity. So don't ever call this guy gravity. But of course for GAMSAT it doesn't really matter. But this guy is not gravity. This guy is gravitational acceleration. So gravity is actually force, but this one is an acceleration. It's a little bit of digression, but if you multiply the gravitational acceleration by mass of the object that is going through that acceleration, then you get the gravity. This is gravity, this is gravitational acceleration, and these two are linked by this mass. Okay? Yeah. I hope that makes sense. Does that satisfy your question, Tanvir? So you asked me, is gravitational acceleration the only acceleration? Well, if you throw an object on the surface of the Earth, gravitational acceleration is the only acceleration. There is no other acceleration unless, of course, like a wind blows in a horizontal direction. But that's unlikely to show up in GAMSAT. Fiona asked me, is it increasing, decreasing at equal? I'm not sure what you mean. Interval. Okay, so here's the thing. So as you go down, the velocity is going to become, so the physical the difference here is this is wider than this one, and this is more distance than this one, right? So when it reaches negative 10 meters per second, it'll be somewhere around here. But when it reaches negative 20 meters per second, this is actual velocity. What I'm drawing here is velocity. But in terms of the position, let's say this is like 0 meters. So let's say that's the reference. This is displacement. This is velocity. Then this would be, let me just quickly calculate this one, 0.5, 10, and then 1. So this is going to be 5 meters actually. And it's going to actually physically move down a bit more because it's moving faster. In this region, it's moving faster than in this region, right? So it is going to move down. It's going to move down to 20 meters. So that gap here is 15 meters. That's 5 meters and then 15 meters, okay? But you don't have to, so we're getting into very deep stuff at the moment. And this is going to be 45 meters, okay? But I don't want you to focus on these increments. Of course, it's covering more and more distance as it goes down. Just for now, just concentrate on the fact that every second, in this case, it's dropping. It's gaining 10 meters per second every second, okay? Hold on. So there's so many questions. Okay, right. So Kanchana, why is velocity negative when the particle is going down? Okay, so we usually assign positive value to upward direction. Downward, we assign negative value for the downward direction. We assign positive value for going to the right, and assign negative value for going to the left. But of course you can change them if you want. But if you assign one direction as positive, the other direction must be negative. That's what you have to do. Tanvir, so when the ball is thrown upward and its velocity decreases because gravity is downward, does that mean it's decreasing velocity due to gravitational acceleration? Yeah, the velocity is decreasing in velocity because of the gravitational acceleration. Exactly. Yeah. Yeah. Kanchana, you're saying, is the sign just to indicate the direction, but the speed of the particle? What's that question mean? Is the sign just to indicate the direction, but the speed of the particle is actually increasing? Okay. We'll come back to that in a minute. All right. Yeah, this part is correct. The sign is to indicate direction. Yes. Yes. Yeah. Okay, so there are many things to cover here, but we're not going to cover everything. It takes time. I don't want to give too much information at a time. And yeah, so we talked about these things, and yeah, maybe we're gonna do this one in the next lesson, these ones here, not today. Let's go and have a look at the, what's time now? What's time now? It's already 6:45, okay. We're going to take a look at this question here. I'm going to take a picture of this. Oh, it's very big. And the question is, so now we know what these are, right? So I'm not going to copy this one. I'm going to copy these two questions here. So this is question 36, 37, so it's sort of like medium level ish in GRE. I mean, not GRE, I mean GAMSAT. Yeah, that's the question there. All right, might have to zoom out a little bit, but it doesn't matter. I don't know how to zoom out. So it says graph of the velocity of 100 meters sprinter throughout the 10 seconds that it took him to run his race is shown in figure 1. Assume the sprinter ran in a straight line. So I'm just going to tell you something. This is not like a typical graph that like a physics student would see in even in like first year university first year course. Okay, so if you give this problem to like someone who is already majoring in physics, it's going to be a bit confusing, because normally what people are given is like displacement versus time, velocity versus time. So usually the x-axis is the time. So this one is very, very confusing though. You can see that there's a velocity here, and there is, so this axis here is distance, or the same as displacement in this case. So what you have is something that doesn't really, it's very unfamiliar stuff. Distance there, and this is the velocity. So GAMSAT is really, it doesn't require, I'm just going to write it here. So maybe there are many people who are looking at these GAMSAT problems for the first time. So GAMSAT only requires really basic knowledge of physics or chemistry. It's all the same as well. Gives you some text, some information, some question full of necessary information. Okay, and it's pretty much testing your ability to quickly grasp the information and understand and apply them, okay, by solving those problems. So that's what they're testing. All right, so that's why there's so many questions, but there's always a way to do them really, really quickly by just using your I would call it so you have to be, so it doesn't just require so the amount of knowledge required is very little, I think, for physics. Okay, knowledge little, but you have to be like really clever, okay, in terms of your time usage. And yeah, so there are always clues. All right, so but obviously it doesn't hurt to definitely, so you know, those equations that we went through, they're really, really basic equations for physics. So if you are a student of physics, definitely you need to know those equations. That's why we went through that, these ones here. Yeah, you do need to know these ones, even though this is the case. All right. So let's have a look at this one. So we know this one, right? So we can skip that. All right. So they provide this necessary information, but of course, if you are good at physics, I mean, if you already know physics, then of course you can just skip that, okay? So for questions like these ones as well, like if you know what they are talking about, then you can skip most of the information here and save time. So that's always the way GAMSAT is set forth. So the question is, I'm going to go back to this one here. It's asking you the best of the following estimates of the time that the runner took to run the final 50 meters is. So total race here is 100 meters. But the final, this is the first 50 meters, and this is the final 50 meters. So let's go up here, and that's the point right there. So from there to there is the final 50 meters, right? And obviously, this doesn't have any time. X-axis is distance, and the y-axis is velocity, so there is no time. So how do you figure out the time? Well, here's the thing. You can just, so this is, it's saying estimates, right? So let's have a look. So the total distance is, 50. And we know that basically, we've learned all these equations. V is equal to U plus AT, and S is equal to UT plus AT, half AT square, and V square, etc., etc. Well, sometimes you don't need these equations. So that's the case for this question right here. So simply let's use this equation. So the distance is equal to velocity. I'm just going to use this one maybe. So distance is equal to velocity times by time. I mean speed times by time. Okay. Sometimes I interchange the word displacement with distance, but they are not actually identical thing. I'm gonna come back to that later when you guys get better in physics. And sometimes I use the word speed interchangingly with velocity, but they're definitely different stuff. We'll cover that in the next lesson. But we know that the distance is equal to speed times by time. So therefore time is equal to whatever distance you cover by the velocity or speed. So you got to look at here. Oh, this here, it's 12 meters per second if you look at it. So this guy in the final 50 meters is going at 12 meters per second. But if he was going at constant velocity of 12 meters per second, it would have been a lot easier. But he's actually, his stamina is falling, and this guy is running, his velocity is slowing down. You can see that. So this is about 11 here. This is exactly 11. But his velocity fell to about halfway between 12 and 11. So this is about 11.5. That's meters per second. So he ran 50 meters. So I'm going to figure out the time using this equation right here. He ran 50 meters. So that's from there to there. Divide by velocity, but which velocity do we have to divide by? We cannot divide by 12, we cannot divide by 11.5. We have to divide by perhaps the average of those two. So that's equal to, so halfway between 11.5 and 12 is 11.75, isn't it? So you have to know that. All right, halfway between 0.5 and 1 is 0.75. That's why it's 11.75. But you don't have, you're not allowed to use calculator, so how do you figure this one out? See? So that's the answer. But the problem is you don't have a calculator, so you got to figure out which one is the answer by your head. But, there is always a way to do this without a calculator. So let's think about this. Suppose that suppose that velocity was 10 meters per second. Then you would take 5 seconds, right? But our velocity is 11.75, not 10. So definitely this answer would not be 5 seconds, because 5 seconds would be the case if you were running at 10 meters per second. So that's not right. And suppose you were running suppose you are running at 12.5 meters per second. So if you know some arithmetic, then you would know that this is 4. Okay, 4 seconds. So if you are running 50 meters at 12.5 meters per second, then you would reach that destination in 4. But definitely, our velocity is 11.75, right? So definitely the answer is not 4. So now it comes down to just those two answers, okay? So you have to do this by process of elimination. All right, so what we have to do next is, I want you to think about this, whether 11.75 is a number that is closer to 12.5 or 10. Definitely it is closer to 12.5 than 10, right? So we have two answers. So we have two answers that are 4.7 and 4.3. So we have 4.3 seconds and we have 4.7 seconds, right? So 4, 4.3, 4.75. But our velocity is 11.75, which is closer to this guy. So our answer must be closer to 4 than closer to 5, which is this one. That's closer to this one. That's closer to this one. So the answer is 4.3. So you see in this question, we didn't use any of these equations, okay? U squared plus 2as, yeah. So we didn't actually use this. Rather, we were actually using this one. We were actually using this one. S is equal to the only equation that this GAMSAT problem didn't provide. We were actually using this one, right? So that's the average velocity, distance divided by the average velocity. Average velocity was 11.75, wasn't it? Yeah, we divided that by that to figure out time. But because we don't have a calculator, we use this clever method here. And by process of elimination, we got the answer as B. All right. Any question, anyone so far? Is that too hard, or can you guys type on the chat box if it's hard, type H. If it's medium, type M. E, easy. Makes perfect sense. Medium. All right, that's good. Easy. Yeah, that's also very good. All right, so I got some question from who is this? Felicity. So you asked me. So if I have the ball traveling at 100 meters for 10 seconds before the velocity is 0, average of the 500 meters. Yeah. Okay. So if we just come back to this one. Yeah, you're right. So the average velocity, so Felicity was asking, so just going back to the previous problem, okay? So if like a ball was launched at 100 meters per second, and like we know that it's gonna take 10 seconds to reach the top, because the gravity is gonna eat away from here 10 meters per second every second, right? So it's gonna definitely take 10 seconds to reach the top. You can figure out the maximum height simply by figuring out the average velocity here. So the initial velocity is 100. Final velocity when it reaches top there is 0. So average velocity is, so what's a u plus v over 2? That's equal to 50, right? So you can multiply 50 by 10, then you get 500 meters for this one. Okay, so that's 500 meters. That's exactly right. You can also use this equation. So so the s is equal to ut plus half at squared. But a lot of people prefer using like this one because it makes a lot more sense to their mind. It does to me as well than this one, because you know who can sort of visualize what time square is, you know. So so that this is a bit more difficult, but you can certainly do this one as well. So u is equal to 100 times by time is equal to 10 seconds. And then this is equal to, this is negative here. So this is negative 5. 10 times by half is 5, right? And this is equal to 10 square. So that's equal to 1,000 minus 500. So you get 500 as well. Okay? Yeah, so I think a lot of people are, so no one's saying very, very difficult, medium or easy. Most of you saying so medium, all right? Now, this one is something, we can try this one here. So the best estimate, so we can try this one and then call it a day. And by the way, I will run another free session this Saturday. So there's a revision class, so we're just gonna do some problems involving those equations, okay? So what I wrote here is this. So for physics, you can only improve by solving many problems. Many people think, you know, when you just go through this and not do any problems, then they're not gonna stick in your head. So I think we'll have another hour on Saturday night, 8 p.m., 9 p.m. Hope you guys can make it. So this one here is, what is the acceleration of the runner over the first 15 meters? So first 15 meters is right here. That's 15 meters, right? 10, between 10 and 20, so that's 15. And if you go up this way, the velocity reached is about 9. Is that right? 9. So that's 15 and 9. But we don't have time for that. There's no time, right? So if time is missing, you know, in this, when I explain all these things here, I told you that you can use this one when time is unknown, right? And they kindly provided this equation in the GAMSAT question. So if you want to figure acceleration, we have s, which is 15, right? And we know that it started from 0 velocity. That's a 0 velocity, you see? So we know this one. We know this one. We know this one. So we can figure out this one, right? So let's try that. Velocity is, the final velocity is 9. So it's 9 squared. Initial velocity is 0. So that's very simple. 0 squared is 0. And this is a 2a. S is 15, right? So this is equal, 2 times 15 is 30, so this is 30a, and this is 81. And a is therefore 81 divided by 30. What do you think is the answer? What is 80 divided by 30? You can just cross out this one, this one, this one, all three of them. Because how many 30s fit into 81? At least 2, right? Because 2 30s is 60. 81 is more than that. So the closest is, this is all about estimates. So if you actually do, I'm just going to cheat by using calculator. So 81 divided by 30 is equal to 2.7. So 2.7 is a better answer, meters per second squared, but the closest answer is D, isn't it? So we're going to call it a day today. Just this is like for me, I'm also learning to teach. So you guys can let me know, like if you guys have any feedback on my teaching. All right, so I can improve teaching. So my plan is to help you guys achieve very good score in GAMSAT, especially in the physics and chemistry area. So. All right, we'll call it a day for today. And does anyone have any question? All right.
Thank you, Johnny.
All right, no problem at all. I'll run another session maybe on Saturday. Yeah, and they're all free for now. Okay.